For the given functions, we want to find antiderivatives or indefinite integrals. Imagine f is a function, which will be with capital F, and if we derivate it, and its derivative is this f of x with lowercase f, then we say that integral or antiderivative of f of x is capital F. But once we derivate the right-hand side, we can get this left-hand side function, or if we have a constant c, derivative of constant becomes 0. So in general, we need a constant for antiderivatives. Now we want to do this for the given functions. If I have integral of 5 dx, we can bring the constant to the front, and then integral of dx is x itself. So it is 5 times x plus c. Next function is still a polynomial. If I have x to the 4 dx, integrating, so we need to do exactly opposite what we did in derivative. We need to add 1 to the power and then divide by the same or the new power plus c. So it is x to the 5 divided by 5 plus c. Third one still can be written in the same form. But we need to bring x to numerator, and it becomes minus 2 dx by the same rule, minus 2 plus 1 divided by minus 2 plus 1 and constant c, for x to the minus 1 divided by minus 1. And we can still simplify and write minus 1 over x plus c. Now the functions, the first two are still polynomials, or we can write another polynomial, let's say power functions. We can convert these roots as x to the some power. So if I have root x times cube root of x squared dx, we can write root x as x to the 1/2 and x to the 2/3 dx. If we multiply, so we cannot integrate term by term if it is in the product form, but if it is in sum form, we can integrate term by term. So we need to simplify first and then integrate. So if I multiply x to the 1/2 plus 2/3, so still we are simplifying, there is no antiderivative up to this point. One more time simplification, common denominator 6, and 3 plus 4, 7 over 6 dx. Now this is power function, and I can write x to the 7 divided by 6 plus 1 divided by the new power. So if I add 7 over 6 plus 1, it becomes x to the 13 over 6. This number also is 13 over 6, but dividing by a rational number is exactly the same as multiplying by its reciprocal. So here we can write 6 over 13 plus c. This is for part D. Part E, in the first two terms we have still polynomials, but for the last one we cannot use the same rule, because when the power is minus 1, if you add 1 to the power, it becomes 0, and we cannot divide by 0. On the other hand, we know that derivative of ln x is 1 over x, so the last one is simply ln x. So if I integrate 2 times x to the 7, 3 times x to the 6, and 4 over x dx, we can write 2x to the 7 dx. However, we don't need to do this step. For now, we just want to show that you can integrate term by term. So the last one is only ln x, and the others are polynomials. So we have 2 times 7 plus 1, 8 divided by new power. 6 plus 1, x to the 7 divided by 7, and finally ln x. But ln x and ln minus x has the same derivative. In general, we should write the absolute value plus c. Last one, 8 times 2 to the x, which is exponential. Integral of 8 times 2 to the x dx. So we can write this 8 here. And if we know the formula for a to the x, we know that integrating a to the x, we need to divide by ln base, ln2. And integral of a to the x is going to be a to the x divided by ln. So here a is 2. The same 2 to the x divided by ln2. So if you remember when we wanted to derivate 2 to the x or a to the x, we multiplied by ln base. Now in antiderivative, we divide by ln base. 8 over ln2, 2 to the x plus c. Another basic functions, but this time we want to use substitution. Instead of 8x plus 5, I say u is 8x plus 5. Then du is 8 dx. Now instead of integral of 8x plus 5 to the 10 dx, we can write, instead of the parentheses, we consider it to be u to the 10. Instead of dx from last equation here, we can see that if I have an 8 here, 8 times dx is du, then since 8 is not there, I can write 1 over 8 du. Integration with respect to u of u to the 10 is u to the 11 divided by 11. And 8 times 11, 88. And u is the same parentheses. You need to bring back to the original variable, 8x plus 5 to the 11 plus c. The same happens for next one. For b, we consider u to be 2 minus 5x. The term inside the parentheses, the term under the radical sign, usually is going to be considered as u. If it is du, then du is minus 5 dx. Or you can still simplify and say instead of dx, we should substitute minus 1/5 du. Now for the integral of 1 over 2 minus 5x to the 4 times dx, we can write this term, which is u, to the 4 in denominator. If we bring to the numerator, it becomes u to the minus 4. Instead of dx, I need to write du divided by minus 5. So then this minus 1/5 is here, and integral of u to the minus 4 is u to the minus 4 plus 1, minus 3, divided by the new power plus c. And finally, u still should be substituted, 2 minus 5x to the minus 3. And you can bring to the denominator and write with the positive power or leave like this. Next one, root 6 minus 9x. So instead of 6 minus 9x, we consider u. Then du is minus 9 dx, or dx minus 1 over 9 du. And finally, integral of root 6 minus 9x dx can be written as u to the 1/2, and dx is minus 1/9 du. I can write minus 1/9 here. So u to the 1/2, 1/2 plus 1, 3/2, so there's minus 1/9 x to the 3/2 divided by 3/2 is the same as multiplying by 2/10 plus c, and finally minus 2 over 27 sorry, this is not x, this is u. We need to substitute back 6 minus 9x for u to the 3/2 plus c. Another substitution. This time, whatever we have an exponent of this exponential function, we consider as u. Minus 2x plus 3. Then du is minus 2 dx. And integral of e to the minus 2x plus 3 dx can be written as e to the u. Instead of dx, I need to write du divided by minus 2, but still I can write that minus 2 here. Integral of e to the u respect to u, the same e to the u. And u is minus 2x plus 3. And that's all. Next one, the term under the radical sign can be considered as u for part e. 2 plus 2 to the x. If I derivate, or let's say differentiate derivative multiplied by the du on the left hand side, u prime du, which is 1 times du. Other side, derivative of this term multiplied by dx, derivative of 2 to the x, ln base 2 to the x times dx. And we can see that this 2 to the x dx exists here, dx and 2 to the x. We need just divide by ln 2. Now the integral, I write in other order. I write first the root and then 2 to the x dx. So this 2 to the x dx can be substituted by du divided by ln 2. So that ln 2 is a constant I can write before the integral. Here we have u to the 1/2 and du. Now u to the 1/2, if we integrate, comes u to the 3/2 divided by 3/2 is the same as multiplying by 2. That our final answer is 2 divided by 3 ln 2. And u is 2 plus 2 to the x to 3/2. Last one, ln x is there, but we have 1 over x derivative of ln x, so it is simple integral. If I consider u as ln x, then derivative of ln x is 1 over x dx. And we have 1 over x dx in the integral. We can substitute that one by du. So we have integral ln cube divided by x dx. We can rewrite this as ln x to the 3. So we substitute this one by u. And dx over x, and dx over x is du. Now the new integral is u cubed du, a polynomial or a power function, which is u to the 4, integral divided by 4, and c. So u is ln to the 4th power. We can write the power here, ln 4x plus c. So ln to the 4 or ln x to the 4. You can keep the parentheses and put the power after the parentheses. And this one is the application of antiderivative. We studied marginal profit as derivative of profit or marginal revenue, derivative of revenue. Now, if we have the derivative, we want to find the original function, which is profit in this case. We know that marginal profit is derivative of profit function. Or if I have the marginal profit and I want to find the profit, so it's going to be integral of marginal profit. But when we integrate, we are going to have a constant. To find that unknown or one constant, we have extra information here. So we know that P is integral of marginal profit, but marginal profit is given to be x squared, 100x, and 1600 dx. It's a basic polynomial. The integral of x squared, x cubed over 3, integral of x squared divided by 2, and integral of constant times x plus c. But we have the profit, but c for now is unknown. So to get the value of c, we have another information. We have one equation, one unknown. If I substitute x by 3, then px must be this value. So if I substitute x by 3, we have 3 cubed divided by 3. 100 divided by 2, 50 times 3 squared, plus 1600 times 3, plus c must be 43, 41. If we simplify and find the value of c, 3 squared divided by 3 is 9. Here 3 squared is 9. 9 times 50, 450, and 3 times 1600. Other side, 4341. It is minus 18. And finally, we say that the profit function px is 1/3 x cubed minus 50x squared plus 1600x minus 18